Welcome to our Assignment 2 project, where we explore the climate, architecture, and sustainable design strategies for our One World Trade Center bus stop. One World Trade Center, often called the Freedom Tower, is the centerpiece of the World Trade Center redevelopment and stands on the site of the September 11th attacks. Designed by David Childs of Skidmore, Owings & Merrill and completed in 2014, the tower rises to a symbolic height of 1,776 feet, referencing the year of American independence. It replaces Minoru Yamasaki's 1973 Twin Towers and fulfills developer Larry Silverstein's commitment to rebuild the site after 9/11. Following Daniel Libeskind's master plan centered on memory, light, and resilience. The building is shaped as a crystalline prism with 8 triangle facades that shift from a square base to an octagon and finish as a rotated square at the top. It features a high-strength concrete core supported by a steel frame and is wrapped in a 13-foot-tall insulated glass panel, the largest ever used on a skyscraper. At sunrise and sunset, the tower's glowing corners subtly echo the presence of the original Twin Towers. Entrances on all sides open to a public plaza designed by Peter Walker and Matthew Nielsen, connecting directly to Michael Arad's 9/11 Memorial, serving both as a workplace and civic landmark. One World Trade Center stands as a powerful symbol of remembrance, resilience, and forward-looking optimism in Lower Manhattan. The climate reflects both New York City's overall weather patterns and the unique conditions created by its dense urban setting and proximity to the harbor. The area experiences warm, humid summers and cold, windy winters with consistently high humidity that shapes comfort levels year-round. Lower Manhattan receives heavy rainfall with regular snowfall. It is increasingly affected by intense storms such as hurricanes, northeasterns, and extreme downpours, which heighten the risk of flooding and storm surges. Sunlight in the area is limited because surrounding skyscrapers cast long shadows, especially during winter, affecting solar potential and how outdoor spaces heat and cool. Wind behaves the same. While typical wind speeds are moderate, tall buildings channel storm gusts into narrow streets, creating strong wind tunnels at ground level. The site's location between the Hudson River, East River, and the New York Harbor also increase its vulnerability to sea level rise and coastal flooding. Combined with limited green space, the urban heat island effect further traps warmth and reduces airflow. These climate factors make it essential for the bus stop to offer shading, wind protection, weather resilience, and adaptability. Moving on to our design, our bus stop generates its own renewable energy through angled photovoltaic panels mounted on the roof. These panels power the LED lighting, a digital arrival time display, and built-in charging ports. A compact battery system beneath the bench allows the stop to operate off-grid even at night or during outages. To manage stormwater sustainably, the roof captures rainfall and directs it into an underground tank. The stored water automatically irrigates the roof and planter vegetation, reducing strain on city sewers and decreasing street-level flooding. Overflow safely drains to nearby green space, supporting climate resilience. The structure uses low-carbon and recycled materials, including a recycled aluminum frame, a concrete base blended with slag and fly ash, and reclaimed wood accents. A transparent glass back panel provides visibility and safety while echoing the clean, reflective aesthetic of the One World Trade Center. Our bus stop also relies on passive design for natural comfort. The south-facing angled roof blocks high summer sun while emitting warm winter light. An extended roof overhang offers shade and rain protection, and reflective finishes reduce heat absorption. The entire structure is placed to take advantage of local winds and solar conditions to improve comfort without mechanical systems. The shelter's geometric design references the tower's iconic prism form, creating visual contingency with the surrounding site. The green roof and side planters support urban ecology by cooling the microclimate, filtering air pollutants, and providing habitat for pollinators. Native sedum and grasses thrive in shallow substrates and require minimal maintenance, making the stop both environmentally productive and visually connected to nature. Our bus stop design incorporates at least 5 LEED-aligned sustainability strategies. First, under sustainable sites, the roof, gutters, and water tanks work together to manage on-site stormwater and reduce runoff. Through the energy and atmosphere category, solar panels provide renewable electricity to power the stop independently from the grid. For water efficiency, all irrigation from the green roof and planters comes from captured rainwater, eliminating potential water use. In the materials and resources category, we use recycled aluminum, low-carbon concrete, and reclaimed wood to lower environmental impact. Finally, under innovation, the integration of solar power, green roofing, and rainwater capture creates a highly sustainable system that exceeds expectations for the typical bus stop. Here are the references used for the information along the way in this slideshow.